Hello students, welcome you all in this session of class 10. The topic is trigonometry. So let us focus on this topic. Since this is new for you 10 class students also, because up to class 9 there is no trigonometry in the syllabus of mathematics. So pay attention so that this concept you may take in a better way. Trigonometry, the literal meaning of this word, as it is made of three words: tri jod gono jod metri. Tri means three, gono means sides, metri means measurement. So this word has meaning three sides measurement, and you know three sides means it is related to a triangle. So although it is a literal meaning only, but actually what happens here, we have a right angle triangle, and you know in a right angle triangle the side opposite to right angle is always at hypotenuse, which is longer side and is symbolized by h. Now there are two acute angles, and for each acute angle, the opposite side of considered acute angle will act as perpendicular, symbol P, and adjacent to that angle, the side adjacent is base, symbol B. As in this figure of right triangle ABC, right angled at B, for angle C I am telling, which is given as theta degree. So for this theta angle, the opposite to this angle, the side opposite to it AB is now P, and adjacent to this theta angle, the side BC is B, and side opposite to right angle B, which is AC, is the hypotenuse. Now what we do, we will take the ratio of two sides at a time. So starting from taking the ratio of P and H with respect to angle theta, then it is AB by AC. This ratio of P and H is called sine of that angle, that is sine theta. Similarly, when we take the ratio of B and H with respect to that acute angle theta, then it is BC by AC. This ratio is known as cos of that angle, that is cos theta. And this time now we will take the ratio of P and B with respect to angle theta, then it is AB by BC. This ratio is known as tan of that angle, that is tan theta. So basically these three ratios are there. Now we will take more ratios just by inverting these ratios or reversing these ratios. So starting from tan theta, we just reverse it. That is in tan theta it was P by V. Now we will take the ratio of B and P. So it is equal to BC by AB, and it is reverse or inverse of tan theta. So it is known as cot of that angle, that is theta. Again, inverse of cos theta, that is reciprocal of cos theta. As in cos theta there was V by H, so here H by V, that is the ratio of H and B with respect to acute angle theta. It is known as sec of that angle, that is sec theta. which is equal to AC by BC. And lastly, we reverse the ratio of sin theta, which was P by H. Now we will take H and P, ratio of H and P, that is opposite to sin theta, reciprocal to sin theta, and it is equal to AC by AB. So this ratio is known as cosec theta, cosec of that acute angle. Similarly, we can find the ratios taking the acute angle alpha, I mean angle A, which is having measure alpha degree. So for alpha, again its opposite side BC will act like perpendicular P, and adjacent to this alpha AB side is base, and hypotenuse is fixed opposite to angle B, right angle, that is AC is hypotenuse. Now taking in the same order as we have taken here for angle theta, we will take one by one the ratio, that is starting from P and H, ratio of P and H. Since every time ratio of P and H is called sine, so here it is sine of that angle, that is alpha, and now it is equal to BC by AC. Similarly, the second ratio is B by H, that is B and H. For this alpha angle, it is known as, since you have already seen that B and H ratio is called cos of acute angle, so cos alpha equal to B by H, which is equal to AB by AC. Similarly, taking the ratio of P and B, so it will be BC by AB, and this ratio will be called tan of acute angle, that is tan alpha. Now we will revert these three ratios. So starting from tan alpha, we just take the reciprocal of tan alpha, so it is B by P, which is ultimately equal to AB by BC. So it is cot alpha, and then we take the reciprocal of cos alpha, that is in cos alpha it was B by H, so here it is H by B. So AC by AB, this is sec of alpha, and last the reciprocal of sine in ratio, that is P by H. Here it will be H by P, and as per side it will be AC by BC, and this ratio is known as cosec of that acute angle, that is alpha. So basically three ratios are there, and three are their reciprocal ratios. So altogether there are six ratios. These ratios are called trigonometrical ratios, and use of these all ratios are finding sides as well as finding ratio when the required things are given. Now let us take one or two questions based on this. You see some questions. First is in the adjoining figure of right triangle ABC, two sides are given. One is AB equal to 5 centimeter and AC equal to 13 centimeter. We have to find out the sine theta. So here theta is angle C, so we may say sine C also, cos C and tan C. So you know, in case of sine there ratio of P and H. So for angle C, P is AB, H is AC. So AB by AC both are known, so it is 5 by 13. So sin C comes 5 by 13. But in case of cos C, when we calculate cos C, then it needs B by H, and B is not given. So we can find out BC, which is B, for theta angle. So by using Pythagoras theorem, b equal to under root h square minus b square, and we find it comes 12. So now cos c equal to v by h, that is bc by ac, so 12 by 13. Again tan c equal to p by b, which is equal to ab by bc, so it is now 5 by 12. So in this way, this question we have done, which is based on the ratios what we have learned just before. Now we take another question which is given 5 sin theta equal to 3, then find all trigonometric ratios. So here it is given that 5 sin theta equal to 3, so we find sin theta equal to 3 by 5. But we know in sin theta it is p by h, so this implies that p by h is equal to 3 by 5. So separating them, p equal to 3k and h equal to 5k, where k is a constant. We know that separating a ratio we must multiply the value by a constant, and traditionally in trigonometry we used to take constant k. That's why such questions are also popularly known as k method question. So now we have p equal to 3k and h equal to 5k. So again we will find out the base, that is QR side, using Pythagoras theorem. B equal to under root h square minus b square. So finally we get here 4k, base equal to. Now we can find all the ratios as sin theta equal to p by h. So it is pq by pr, which is equal to 3k by 5k, and cancelling k we have 3 by 5. Similarly cos theta equal to v by h, which is ultimately equal to qr by pr, and it is equal to 4k by 5k, which is equal to 4 by 5. Tan theta equal to p by v, that is pq by qr, so it is equal to 3k by 4k, and cancelling k we have 3 by 4. Cot theta equal to b by p, which is equal to b by p qr by pq, so it is equal to 4k by 3k, that is 4 by 3. Sec theta equal to h by b, that is pr by qr, so it is 5k by 4k, so it is 5 by 4. And cosec theta equal to h by p, which is equal to pr by pq, that is 5k by 3k, and ultimately it is 5 by 3. So such question can all be solved by using the ratios of trigonometry. So let us stop here, student. Hope that all things are clear, in spite of new things for your class. So again in the next video we will see more of trigonometry. Till then, thank you, have a nice day, and you must share your feelings, comment, and don't forget to subscribe, students.